Good morning, Year 12. We are looking at our new topic called Annuities. It is the final topic you will do on financial maths before your HSC. And today we are breaking up exercise 7A. So there's going to be a couple of lessons on just 7A. So we're looking at just solely questions 1 to 5 today, plus the background information. You need to have an understanding of how annuities work. You can't just use the formulas that you get given. The Band 6 students are the ones who have a really deep understanding of actually how this relates to the real world. So, what is an annuity? Well, an annuity is an investment that you're contributing to. So what that means is we look at 2 different types. Basically, you can have an account that you owe money to, or you can have an account that you save money. They're the 2 different types of accounts you could have in the world. So an account that you owe money to, we call that a loan. An account that you save money to, that's an investment. So they're the 2 types that you have, okay? Now, I'll make it about my life, just as I always seem to do. My loan is my home loan, okay? So we all know, we've seen before, that I have a home loan. So it's an annuity. I make regular contributions to it. Then I also have a savings account, okay? So I have a home loan and a savings account. Not only do I just have a savings account, I also have superannuation, which everyone does who earns over a certain amount of money in Australia. So it's a type of investment where you're saving money. All right, now, what makes something an annuity? We know about accounts and loans and investments before, but why do we suddenly call it this new word of annuity? Well, think about every single thing you've ever learned in financial maths. It's usually to do with interest. We've looked at an account, a savings account, and we look at how much interest it'll grow to if your percent interest rate is something. What makes something an annuity is if you are making contributions to that account. So now imagine, you've got your savings account, you've got an interest rate, but imagine now if you contributed $100 a week to that savings account. That makes it an annuity. The same thing as if you have a loan. We've looked at loans before, and we look at interest rates and how long you might have it for. But now what happens is we say, well, what happens if you are paying off your loan at $300 a week? Making it an annuity. So to break it down, an annuity is where you're making regular contributions. So, let's think about superannuation, or it could be a savings account. Okay, so that's this type over here. That's our first example. Let's say that you contribute $100 a month into an account as your savings, or you could think of it as your superannuation. And they said, okay, the interest rate is 15%, which is about what superannuation accounts make in interest. So let's look at the first thing. The value 1 I'm calling is the value after the first month, because these contributions are made per month. So let's think about this. I'm going to have the $100 that I contributed, and then it's going to be charged your 15%. It's very similar to that compound interest formula. Okay, I've set it out in the exact same way if you prefer to think of it as that. All I've got is my present value is $100, 1 plus my interest rate, and the number, what month we're up to, is the number 1. So all I've done is I've substituted into that compound interest rate formula. Okay, which means that at the end of the first month, when you put this into your calculator, I have $115. So it started as $100, it made 15% interest, now it's $115. So now let's think about the second month. Now in the second month, what happens is that $115 is what I'm starting with. The second month says, okay, you've got now $115. It's going to be charged interest at 15%, but you also make another contribution. Okay? So I'm going to call my contribution a down payment. Okay, so let me just run back through that. The first month you contributed your down payment was $100. It was charged 15% interest, which was that second part, which gave you $115. Now in the second month, you're going to have that $115 from last month. It's going to be charged interest, but then you make another down payment that month because every month you're paying $100 into this account, remember? Which makes it that annuity, which gives me $232.25. Now, my $232.25 is charged 15% interest in the third month, but then I add on another $100, which gives me this much money. So it's compound interest because I'm earning interest on the amount from last month, okay? So the next one would be starting with $367, it would be charged interest and then another $100. So I hope that you can understand what's happening there, okay? Your amount is being charged interest, but then you're adding $100. Then that amount gets charged interest and you add another $100. That amount gets charged interest, you add another $100. And notice how I've put this arrow in each time to show you that we keep recurring that number back down, okay? We're not always just going back to the 100. It's the amount that you earned and had in the account at the end of the first month is then charged interest in the second month. And that is the definition of compounding interest. So, what do we actually call that when we keep using that same number and bringing it down? It's a recurrence relation. So a recurrence relation is when the previous result is used to find the next result. So pretty straightforward. And that's what you're doing here when we're looking at that. So what did we do each time? Well, let's think about this. Now don't get too confused about all the letters and numbers here. My second value, so think about my value 2 here. It used value 1's result. Then it charged it interest, and then it added that down payment again. Okay, so the official formula for these types of questions in annuities is given to you in this blue box. Don't be afraid by what this means. Think about it back in relation to this question. V2 would be here, and you take V1, it's charged interest, and then you add on your down payment. It looks confusing, but if you have the understanding of how these investments work from up here, hopefully you can now link it down to this formula. Okay, now let's look at if I had to repay a loan. So remember, this was type 1, where I'm looking at a savings account. Now, a loan is what I'm going to look at further down here. It's the second type. Okay, and I'm going to, of course, use my own experience with my loan. So, I have a loan of $300,000 in my bank. And this is real life, I actually do. Now, I make weekly repayments of $350, and the bank is charging me 2.9% per annum in interest. The first thing I'm going to think about is, well, I know from all of my financial maths experience that if something's in week, I need to make sure everything's in week. So I need to turn that 2.9% per annum into weeks, which you can see is what I did just here. I divided up into 52, and then I divided it by 100 to get rid of that percent, because remember we put it as a decimal in the formula. So my new rate becomes 0.0055769, okay, per week, which I just rounded for this question's sake to 0.006. Now, let's think about after the first month, what do I have owing on this loan? Well, what happens is my $300,000 loan, it gets charged interest, okay, at 0.0006, okay, percent. So it's charged interest, but then this time, because it's a loan repayment, this is what I still have left owing on the loan. But then I take off $350 that I paid off the loan. So notice the difference between a savings account up here, we were adding on that down payment because we're adding to that savings. But this time on a loan repayment, I'm subtracting it off because this is how much I have owing on the loan, but then I take off the $350 that I've just paid off it. Now when I put that big long part into my calculator, I get the answer here. Okay, so now let's look at what I owe after the second week. Well, I know that I have this $299,830. It is from what I had left owing after the first week. It's now charged interest again. But then I make that weekly repayment and I pay off $350, which gives me my next value of $299,659 and 89 roughly cents. Okay, after the third week, my amount that I had left owing from last week gets charged interest again, and then I pay off my $350 repayment and I get my value. So hopefully you can see it's just going to keep doing this every single week. It takes that recursive relationship, it takes that answer from the week before, and that is charge interest. It takes the answer from the week before, and that is charge interest. Okay, so now that makes our new formula for when you're paying off a loan. It's the exact same formula, but this time instead of adding that down payment, I'm subtracting it off. Because this, when you're paying off a loan, it calculates what is left owing on the loan. Okay, and that might be something to note in your notes here. So what is left owing on the loan? Okay. All right, so you've got two formulas. You have it when you have an investment or a superannuation and you're adding money and building it up. And then you have it for a loan where you're paying something off. So now let's have a look at how we can use these formulas. So you've got your two formulas here. I did mention that this is quite a difficult topic. It's one of the hardest topics you are going to do. And if you're finding this difficult, it's okay, it's supposed to be. Advanced Maths, they do this topic as well. So, if you don't fully understand that behind the scenes deep understanding that I just explained, it's okay. You can still get by very easily by just doing the formulas and having a small understanding. So let's have a look at what the start of 7A, pardon me, questions style looks like. We're going to start with investment style questions. The question says, an investment is modeled with the recurrence relation given this. Calculate the amount the investment is worth after 2 repayments, given that V0 is 2,000. So you're thinking, what does that mean? Well, let's think. Straight away, it's an investment. So we're thinking about our investment formula. which we know is this value. And notice all they've done is substituted values in. So 1 plus the rate became 1.02 because my VN is timesing by that. And the down payment they're making, so they're adding to this investment, is $300. So this is what they are adding to it. Each repayment they're making, they're adding $300. So think about it in real life. This is a savings account. We take the value, it's charged 1.02 in interest, and then you're adding $300 to it every repayment. So it says, what is it worth after 2 repayments? V0, whenever you see the value at 0, it just means the initial value. So initially in this bank account, there's $200. $2,000. So let's think. Value 1, so at the end of the first repayment, and now they haven't told me whether this is in weeks, whether it's in months, whether it's in years, so we're just saying at the end of the first repayment, there's going to be the $2,000 from the initial amount. It's going to then be charged interest, and then you add on the $300. Now let's think about, all I have done here is V0, okay? When I find V1, all that is V0 plus 1, which gives me V1. So V1 equals my V0 amount, which is what this says here. I have to times it by the interest rate and then add 300. They gave me that formula there. So I just use it. I sub in the value. Now that is what is going to be in that savings account after the first repayment is made to it. And instead of calling it a repayment, it should be really called just payment. Okay? You're not repaying it into a savings account. You're just paying money into a savings account. So put that in your calculator, and that's what we get. So after the first payment is made, that $2,000 earned interest, and then you also added $300 to it. So the account grew to $2,340. But it doesn't want that. It wants, well, what's it going to be after the second payment's made? So when the second payment's made, subbing into your formula, you're going to have VN. Okay? So I'm looking at VN plus 1. I'm looking at V2. So now I take that value, I put it in here. Now, that's my VN part. It's being charged my interest, and then I add 300 to it. Okay? Putting that in my calculator will give me a final value of 2686.80. So that is what my savings has grown to after 2 payments are made. That's the answer. So again, I might be sounding like I'm making it complicated because I'm trying to get you to have that deep understanding of where things are coming from. Otherwise, all we did was sub values into that formula that they gave us in the question. Okay, now let's look at doing the exact same thing, but this time it's that second type. It's the loan. Okay, so rather than a savings account, I'm paying off a loan, which is where that minus the down payment comes in. Amy takes a loan of $4,000. Using the recurrence relation, they gave you the formula, calculate how much is still owed at the end of the first 4 repayments. So I need to go up to V4. So the first thing I'm going to say is, well, V1. It's the initial value. It's charged interest. But then I make a down payment of $590 to pay it off. Putting that in my calculator, see what I get. So what does that mean? I got an answer of $3,442. So the loan was $400. It got charged interest, but then I paid off $590. So now after the first payment, I now only owe $3,442. So now we go to V2. We say, okay, well, my $3,442 that I have left owing, it gets charged interest. Then I make a repayment. Put that in your calculator and see what you get. $2,879,536. So now after the second repayment, I now only owe $2,879. So then after the third repayment, it's going to be that amount. It gets charged that interest again, minus my $590. See what I get. $2,312.57. I'll just do the 3 decimal places, 2. And remember it wanted after the first 4 repayments, so now I go up to V4. I bring that number back down, times it by the interest rate, take off my repayment. So what is left owing on the loan after I made 4 repayments is $1,741.073. That is to 3 decimal places. And that's it. Okay, so if the question asks you for what's owing on the loan after the 4th repayment, you have to do all the ones before. You can't just sub the values straight into the formula with V4, because you need to know what V3 is to put into here. And to know what V3 is, you needed to calculate what V2 was. And to know what V2 was, you need to calculate V1. So they don't ask you, they'll never say something like how much is still owed after the 15th repayment, because that means you would have to do this 15 times. It's usually only small numbers to get you to do that. Okay, so that is the first lesson on the topic. It is a lot to take in, I know. And if you're not understanding it completely, that's okay. That's why I'm breaking down exercise 7A. So I want you to have a go at just questions 1 to 5 today. And it's literally just doing what we've just done 5 times to practice.